Okay, so in this lesson, we are going to learn how to actually maximize some quantities. So in this example, we want to maximize volume. Imagine that we have an 8 by 5 card and we want to cut off corner squares and then fold it up to make an open cuboid. An open cuboid is of course one that does not have a top. It only has 5 faces, right? The 4 sides and the bottom. So we cut off these corner squares here. We could, guess and try to check what has the most volume, or we can use calculus to determine exactly and accurately what the greatest volume we can get from this 8 by 5 card by cutting off the corner squares. So what we need to do is first we need to set up our problem. What do I mean by that? I mean we need to identify our variables. So here we're dealing with volume. And we know that if it's a cuboid, the volume of a cuboid is given by length times width times height. So we need to get an expression in terms of x for the length of our cuboid. Imagine if we were to cut off x from this side and x from that side, and then it folds up like this. What would be the length of our cuboid from here to there? Well, if the entire length is 8 and we take off x from the left and we take off x from the right, we are taking away 2 x's. So the length of the cuboid will be 8 minus 2x. Similarly, for the width of the cuboid, we take off x from the top, we take off x from the bottom here. We're taking away 2 x's from the 5, so we have 5 minus 2x. What about the height though? Well, here, imagine that just comes up like this. Same thing for that piece, it just comes up like that. What will be our height? Our height will simply be x. So we need to now get an expression for the volume of this particular open cuboid. So we multiply the length of 8 minus 2x times the width of 5 minus 2x times the height of x. So let's first expand brackets here. Using the FOIL method, 8 times 5 is 40. Then 8 times negative 2x is negative 16x. Negative 2x times 5 is negative 10x. And negative 2x times another negative 2x gives you a positive 4x squared. So we have to multiply this expression here times the height, which is x. So x times 40 gives us 40x. Then negative 16x squared, then negative 10x squared, and finally plus 4x cubed. Now we have like terms that can simplify. So let's simplify and clean this up a little bit. What do I mean by clean it up? We should have it in terms. We should have it in ascending, we should have it in descending order of terms. So our 4x cubed should be written first. Then our x squared terms, when we add those and keep the sign, we get negative 26x squared, and then finally 40x. So this is the expression for the volume of this cuboid. We want to maximize the volume of the cuboid. So to maximize, we need to differentiate, set equal to 0, and then solve for x. So when we differentiate 4x cubed, that will give us 12x squared. Differentiating negative 26x squared gives us negative 52x, and differentiating 40x just gives us 40. So we set that equal to 0. Then here's a little tip that I am giving you, one that I like to use. When I look at this equation here, I notice that all of these 3 terms are divisible by 4. They have a highest common factor of 4. So if I divide by 4, then I will get 3x squared minus 13x plus 10 is equal to 0. Now, that is not an absolute, you have to do it kind of step, but it is one that I recommend, especially if you're working without a calculator like I am. I prefer to exercise my brain and do these without a calculator. So here, this is a big help because it makes these numbers much smaller and more manageable to deal with. What I mean by that? I mean that here, now I am only squaring 13 instead of squaring 52. I can square 13 in my head, that's 169. 52 squared, that's a whole nother ball game, right? So when I substitute into the quadratic formula, like we have learned how to do from the previous lesson, I'll get 13 plus or minus the square root of 169 minus 120 all over 6. So the difference between 120 and 169 is 49. The square root of 49 is 7. So I'll have 13 plus 7 all divided by 6. 13 plus 7 is 20. 6 goes into 20 3 times with 2 remainder. 2 over 6 is 1/3, so that is 3 1/3, right? And the other one is when I subtract 7. So 13 take away 7 is 6. 6 divided by 6 is 1. So here now you might say, well, you get 2 answers. So there's 2 possibilities. But in actuality, there is not. There is only one possible answer. How is it the case that there is only one possible answer? Well, because in a real world sense, only one of these answers will coincide with reality and the other will contradict reality. Let's see what I mean by that exactly. If we consider this 3 1/3 as our value of x, and we try to determine our length of our cuboid, 2 times 3 1/3 will give you 6 2/3. So if I subtract 6 2/3 from 8, that will give me a length of 1 1/3. But if I try to find the width using this value of 3 1/3, 2 times 3 1/3 is 6 2/3. If I subtract 6 2/3 from 5, I will get a negative answer for that width. But the width is a length. In reality, a length cannot be any number that is negative. A length is just a distance. All distances have to be greater than 0. It cannot be 0, it cannot be negative. If a distance is 0, then there is no distance. And it definitely cannot be negative. Alright? Keep in mind that a displacement can be negative, but a distance cannot. Alright? The width of a cuboid is just a regular old distance, and it cannot be negative, which the 3 1/3 would lead to in terms of the width. So 3 1/3 is a no-no. When x is 1, let's see what that will give us. 8 take away 2 times 1 is just 8 take away 2, so that is 6. 5 take away 2 times 1 will give us 3. And then when x is 1, that's just 1. So now we can proceed to find the greatest volume. The greatest volume is length times width times height. So we have 6 times 3 times 1, which is 18 cubic inches. This is our final answer. That is the maximum volume. You can try and guess other values, but none of them is going to give you a volume greater than 18 cubic inches. If you tried maybe an x value of 2, or maybe an x value of a half, or maybe an x value of 1 1/3, any other value you try, none of them will give you any volume greater than 18 cubic inches. And you can check this answer by using your first derivative test or your second derivative test to see that this value of x equals 1 is indeed your maximum volume.